Good day everyone. Today we are going to show you how to solve polynomials using secant method through a C++ program. Secant method is one of the topics under the open methods in solving nonlinear equations. It is a root-finding algorithm that uses a succession of roots of secant lines to better approximate a root of a function f. In this presentation, we are going to demonstrate solving polynomials using secant method through a C++ program. Scope and limitation. This program is created to solve polynomials using the secant method. This program obtains the root of a polynomial with third to 10th degree since quadratic equations can be solved using the quadratic formula. This program includes displaying the tabulated data with a specified number of decimal places as well as the computed error to achieve precision of the roots to be solved. This program has conditions needed to be met, and if not satisfied, the user will start from the beginning. Lastly, this program will stop once the approximate percent relative error computed is less than the pre-specified criterion set by the user. Let's begin!
This is the purpose of the C++ program, to solve a root of x sub I plus 1 of a given polynomial with degrees ranging from 3 to 10 using the second method. Here is the flow of the program. We will start by entering the degree of the function. The program will ask, is the input 3 to 10 degree only? If yes, the user will enter the corresponding coefficients. If no, we will start at the beginning by entering the degree of the function, which is 3 to 10 degree only. The next process is to enter number of decimal places to be displayed. Next is enter pre-specified criterion. Next is enter initial values of x sub I minus 1 and x sub I. Here the program will ask again, are the values not equal? If yes, it will proceed here. If no, we will start at the beginning again. Here, we will solve the x sub I plus 1 is equals to x sub I minus fx sub I times fx sub I minus 1 minus x sub I, all over fx sub I minus 1 minus fx sub I. Here we will set the x sub I minus 1 is equals to x sub I. And here is we will set the x sub I is equals to x sub I plus 1. Here the program will ask again, is the approximate relative percent error is less than or equal to the pre-specified criterion? If yes, it will print the root of the x sub I plus 1. If no, we'll start again here by solving. And after we print the root, this will be the end. And that's all.
Prior to the start of implementing and utilizing the program, let us have a quick sneak peek on the behind the scenes of the program created. So here you can see a lot of codes and commands used in order for the program to properly function. And to further analyze, appreciate, and visualize these codes, let us run the program. So if you are using the dev C++, just press execute and run, or simply press F10 on your keyboard. So as we run the program, here are the following texts that are already printed out. For the title, we have the secant method calculator. This program obtains the root of a polynomial with third to 10th degree. For the direction, we are asked to input a polynomial with degrees ranging only from 3 to 10. So for my example, my highest degree is 6. Its corresponding coefficient is 2. For my x raised to 5, its coefficient is negative 13. For my x raised to 4 is 26. For my x cubed is negative 7. For my x squared is negative 28. For my x raised to 1 or x is 20. And I don't have a value for the constant, so I will put 0. So this function is read as 2x raised to 6 minus 13x raised to 5 plus 26x raised to 4 minus 7x cubed minus 28x squared plus 20x. For the number of decimal places to be displayed, I prefer up to 6, and for the pre-specified criterion, 0.00001. So for my initial value for x sub I minus 1, I'll put 6, and for my x sub I is 7. Here we see that we obtained one of the root of the polynomial we are solving, which is, therefore, x sub I plus 1 is equal to 2.5 at the 20th iteration. So it stopped at the 20th iteration because the approximate percent relative error at this iteration is less than the pre-specified criterion. And this is how this program works. Now, let's try what if we do not follow directions. For instance, I will put a degree which is not within the specified range. For example, I will put 2. And this is what happens. We are requested to please enter a degree between 3 and 10. Therefore, we are going to rerun this program. And for another what if, as stated by Mr. Alvarez a while ago, what if we input initial values for x sub I minus 1 and x sub I of the same value? Okay, so let me re-enter the datas of the function we solved a while ago with a degree of 6 and corresponding coefficients 2, negative 13, 26, negative 7, negative 28, 20, 0, and number of decimal places up to 6, pre-specified criterion up to 0.00001, and for the initial values, let's say I'll put 2, and for the x sub I, I'll also put 2. So this is what happens. The program prints out the initial values you entered are equal and requests us to please input different initial values. So once again, we are going to rerun the program and follow the directions in order for this program to properly function and to obtain the root of the polynomial we are going to solve. To wrap things up, by following the direction, this is what the output of the program should be. Thank you for using the Secant method calculator. This project and presentation is submitted by Alvarez Gemuel Andrew A. and Topacio Rona Jane P. of ECE 301 and submitted to Engineer Danville Rex R. Garcia, Lecturer.